Hey there. Today I'm going to go ahead and show you a really good way to make API requests using Redux Saga. This is a good pattern, a good architecture that I use in my projects, and I think it'll help you out as well. So to start, I'm building off of my previous video where I set up a new React Native app from scratch and integrated Redux Saga and Redux into it already. If you'd like to follow along, simply go to the GitHub repo, the app that I built in the last video, which I'll put on the screen now, and you can go ahead and check out the branch No Query API. That's where I'm going to be starting from and building out the ability to query the API throughout this video on the master branch. So if you want to follow along with me from the beginning, clone the project if you don't already have it, and then check out the No Query API branch like this. So after you do git clone, you do git checkout No Query API, and you'll be on the same step that I'm at. And just to show you, right now I'm in the app directory under models, under user Saga. So this is the Saga we set up last video where we're just modeling getting user info and then putting an action to Redux called get all user info request success with a payload of some user information. This gets sent to the reducer we set up and gets passed to the state object, which in the end our home component here is taking. We're extracting it from map state to props, ID, name, and email, which we sent out here, ID, name, and email in the payload. The reducer set the initial state, replaced it with it, and now we're extracting it and simply displaying it on the screen. So in addition, I also have a terminal running. I just ran npm start, and I opened up my XC workspace file. And so Xcode is here, and I just started up the simulator. So we can see the demo data that we're getting back from the fake API call here, right? We're just yield putting a fake payload. This video, I'm going to go ahead and show you how to actually reach out to your own API or an external one. A really good architecture and a good way to get going. So let's jump right in. Okay, so my first step is going to be to open up the app directory, open up models, and inside of models, I'm going to go ahead and create a file. I'm going to call it queryapi.js. And we'll see what this file is going to contain in a second here. What I like to do is separate out the logic that actually handles querying the API itself, making the HTTP request. I want to centralize that all into one file, one place, because you can imagine in the models directory we'll have many other folders here besides just user. Each one will have its own Saga. Each Saga file is going to have many functions that are all going to call an API at some point. And it's a good place to centralize that, so if we have to make changes to how we query the API, we can do it through this one file instead of going in to change all the Sagas. So in query API, we're going to create a generator function because in the end, these Sagas are going to be calling this query API function. And it's going to be a generator function just calling another generator function. We're just abstracting this code out. So we'll go ahead and start by creating a function called query API. This is a generator function. Notice the asterisk. Okay. And as a parameter, I'm going to pass in an object. I'm going to destructure my parameters here, and I'm going to take in 3 parameters. First of all, I'm going to take an endpoint. This is part of the API we're going to hit. I'm going to take in a method, which is get, post, any HTTP method, and then finally the body. And this can be set to null because if we have a get request, we're not going to have a body. So we can set that null in case we don't even need to provide it. That's okay. So we've created query API function. And my first step here is going to be to go ahead and import a couple of things from Redux Saga. So we're going to go ahead and first import 3 different things from Redux Saga effects: call, put, and select. And we'll see what these do. This is Redux Saga /effects. Okay, now the first thing I'm going to do in the query API function is I'm going to select my current state. And I'm going to do this by calling yield. I'm going to take advantage of the fact we're in a generator function called yield select, which is this Redux Saga method here. And what this does is it just extracts the state out of our application. In a root reducer, we have one reducer right now, the user, which has an initial state. So we're just extracting the state so we can use it inside of this query API method. And you might be wondering why we need state at all in this query API function. The reason why I'm extracting the state right now is when we query the API, I'm going to assume that we need to pass some sort of access token or JSON web token, some sort of authorization that you probably would be storing in your application. After you did a login flow, you'd store this. So to emulate this, what I'm going to do is I'm going to go back into my user reducer and I'll just add another property here called access token. In reality though, this token would be replaced and stored after you signed the user in and had access to it. And you'd have to use it from then on to make requests to whichever API. In this case, I'll assume you'd be using your own, so you can authenticate the API request. So next, in query API, we'll go ahead and actually make the request. And in order to do this, what I'll go ahead and actually do is create another function, and I'm going to call it make request. This function is actually going to be making the request, the HTTP request that is itself. It's a good idea to keep your functions very small, concise, and focused. So this function will just be concerned with making the actual HTTP request using the fetch library. So it's going to be an async function. It's going to go ahead and take in similar parameters, an endpoint method. It's also going to take headers and a body, which will set to null if it's not passed in. So notice this is an object. I'm destructuring it as we did up here. And inside of this function, we're going to keep it nice and simple. We're just going to return a call to fetch. And what I'm going to pass into fetch first is the API URL. In most of my applications, I like to define my API URLs in a separate file, some sort of constant file. So let's go ahead and do that now. So in the root of my project, under the app directory, in the utils folder we already have, I'll go ahead and create a new folder. I'll call it config. And this folder would contain any configuration. So in here, I'll create a new file. I'll call it urls.js. This is going to be constants that we'll define. And in this case, I would create a new const called API URL. Now for this video, I'm just going to use this fake API I found online that simply just gets and posts new blog posts. If you wanted to create your own API, I have a video on how to do that in Node.js Express using AWS Lambda as a proxy. You can check that out if you want to learn more. But this demo API will work for us. So inside of this file now, I'm going to go ahead and just export the API URL. Now inside query API, we can go ahead and import this URL from utils config URLs. And you might be wondering why I would go through this trouble defining this extra file. Well, it's just good practice because now in case we have a local API URL, which usually do, we'd have one production URL and a local URL. You can quickly swap them out here, and everywhere in your application which you use API URL, it'll be quickly swapped out as well. So this is just good practice. Now back to make request. Looks like I'm missing an arrow here, and inside of make request, I'm gonna go ahead and return this fetch call, which we've set up here. Now that we have the API URL, I'm just gonna pass it in, and I'm also gonna append whichever endpoint we've attached. So you can imagine this URL is just the root URL for API, but if we had additional routes on this URL, like /post/ whatever, that's what we'd append here in this fetch call, which we've passed in the query API call, which we'll do in a minute. So the second parameter fetch takes is the actual information that the request entails. So we have the method here, we have headers, and body. Great. So now we have the make request set up, which is making an API call using the fetch library, which we have access to. We pass in the API URL plus the endpoint and the method headers and body. So now in query API, we can go ahead and actually use this. Let's go ahead and create a new variable const called res. This will be the actual response from the fetch call. And we'll use yield call. This is how you call other asynchronous or generator functions in Redux Saga. You use call. And the first parameter is the function you want to call, the second of which is a list of parameters. So in this case, we're really just passing in the endpoint, method, and headers. Now the headers will have to go ahead and set an authorization header here. So in this case, the API I'm using doesn't require authorization, but in all likelihood, your API will hopefully be locked down, and you'll have to pass this in. So we have access to the state up here. We'll destructure it and look at the state.user.access token. If you recall, we added this in here earlier with the test token. In reality, this would be the real access token that you have for your project. Now we just need to go ahead and actually add some template strings here, because if we make this call, we'll have to add bearer first, right? And then we can add the access token. So in the header, we have authorization set to the bearer and then the access token. So one question you may have is, if we use the same query API function for every request, which includes our call to logging in to our API, how are we going to pass in an access token if we don't have one? The login route is responsible for getting it in the first place. So to fix this, what I'll do is I'll just go ahead and add a ternary expression and say, if we have an access token, just attach it to the request. If we don't, then we can just attach null here. So if this is the request to our login service, we won't have an access token. So this will handle that case. And in reality, your reducer wouldn't have an access token here to begin with. We would just have set this to null in our initial state. Once we logged in, this access token would get replaced. Next, I'm going to go ahead and add a content type. 99% of this time, this is going to be set to application.json. If you have a different use case, you can add some logic to separate that out here. Next, we'll go ahead and add the body to the request. And we'll have to stringify the body. And what I like to do here is just unpack it. And what I like to do here is just use the spread operator to stringify a new body object. So I'll add a comma, save, and this is looking good. So now we're actually making the request, and this is pretty much everything we need to actually make a request. What I'll go ahead and do now is just add a few extra goodies to this function, which might help you out in your application. So one other check that I like to make in this function while I'm here is to see if the API response that we got back, the status was set to a 401. If that's the case, then the access token we provided was incorrect or expired. So here, this is where I would log the user out and explain that they need to log back in. So whatever that looks for your application, this is where you want to do that. You log the user out, tell them you need to log back in, get a new access token, and our queries should be good to go after that. So the last step of this function, the query API function, is to actually parse the response and return it to the Saga. So it can, in turn, pass it back to the reducer and update the state of our application. So I'll create a new const here. I'll call it Parse Response. And I'm going to call a new function because we're starting to do quite a bit here. Remember, we really want to separate our logic into individual functions. So we'll create a new function here called const parse response. And this is going to be asynchronous. it's going to take one parameter, just the response itself. So this should do. In here, I like to create a let parse response. We'll create a try block. We'll set the parse response equal to await response dot clone, because we can only consume one response, so we'll have to clone it, turn it into JSON. And if for whatever reason this failed, we'll add a catch block here. And if for whatever reason cloning it, turning it into JSON didn't work, what I like to do is just try and turning it into text, because maybe we can get something a little bit more explainable, something that'll help us understand why the response didn't work. And lastly, we'll just return the parsed response here. So this is great. We'll go back up to our query API function. In the call here, we'll pass in one parameter, the function we want to call, in this case, parse response, and we're going to pass in the response. So in turn, this is going to parse the response, turn it into JSON or text, turn it back to us, and now what we can do is, I like to add a check here. I'll say if the response wasn't okay, and this is something that most APIs, if you create your own, you'll have this. If the response didn't work okay, or you can add another check based on the API you're using. This is where I would throw an error in the application, or really do whatever you need to do. If you don't have some other logic that can handle a bad response. So maybe you want to pop up to the user letting them know this is your last chance to kind of handle this generically before you return the parse response back. So if something catastrophic happens here, handle it. Otherwise, we'll just return the parse response, and this query API function is pretty much finished. And I can see here that I actually need to return the parsed response. We save, and this is good to go. So what I'll go ahead and do is I'll just go ahead and export the query API function. So now let's test our work. If we go back into models, user, sagas, now we're inside of this Saga itself, we can actually import the query API function we just created. Let's go ahead and do that. Import query API. I think it's just up one here. There we go. So every Saga would import this query API function, and now we have access to this in our Saga, which is great. So now, instead of sending in kind of a fake payload here that we hard code, we can use our query API function to get dynamic data from an API and reset our state with that information. So let's go ahead and do that. We'll go ahead and create a variable called posts, or actually I'll just call this I'll call this posts, because remember, our API is just a demo post API. You would obviously replace this with something more descriptive based on the information you expect back from this call. So I'm going to use yield call, because remember, Redux Saga, to call another asynchronous or generator function, we use this call method, right? So I'll call, and the first parameter is the function that we want to call, so we know it's query API. And as you remember, in query API, we're taking in one object with three different properties. So let's go back to our Saga here and create an object, open it up, and remember, it takes three properties. The endpoint. So in this case, I'm actually just going to go ahead and query the root of this URL here, just get the posts. But if you had more information to attach to URL, you would do that here. Then I'll go ahead and get my method. This is going to be a GET request. And since it's a GET request, we're not going to pass in a body, but if this were a post, this is where we would pass in a body and pass in any body info for the request. In this case, just a GET, we don't need to do that. So save. Now I'll go ahead and log out post response, and let's see what we get here. So we should be calling getAllUserInfo when we start up the app in our home view. So we should be getting some information. We go ahead and refresh. the app. All right, we're not seeing any logs here, and potentially that could be because we're handling this error silently. Let's console log the error here, see if we see any more info. Save, and it looks like we're getting the error, body not allowed for get or head requests. So let's go back into our query API and look at the make request function. We can see here, okay, so I think the problem here is, let's add a ternary expression. We'll say if the body is equal to just an empty object, which if we had a get request with no body, it was just set to null and we're spreading it. That's what it would look like. So if it's an empty object, we'll set the body to undefined, otherwise pass it through. Let's hit save again. And now, look, this is great. So we're getting this response back from the fake API that we called here. It's just a list of posts. So to see this a little bit better, what I'll do is I'll go back to my Saga, and instead of the name here, I'll be a little cheeky and I'll just pass in the posts. It looks like we need to access the first element of this array here and then destructure the body in there. If we save this now and go back to the simulator, we can see this Latin text, this post we're getting back. This is the first element. Looks like there's many other posts, but the point is you can see we're reaching out to this API, we're getting information back, and we're updating Redux dynamically here. So this is how I like to query an API using Redux Saga. In the end, we really just want to abstract this API call out to a separate file and do a little bit of logic here, but really not a lot of work. And in the end, each of our sagas can use this query API and get dynamic data quickly and easily. So hopefully this video was helpful to you, and stay tuned for more like it.